My name is Rick Crosslin, and I love teaching science. And today, we're in for a treat because today's lesson is going to be, well, it's going to be electrifying, or at least enlightening, because we're going to work on circuits and we're going to learn how energy, a type of energy called electricity, moves or flows through different objects to do some work for us. And so let's get started. All of you should have a couple pieces right here. If not, your teachers will get them to you, and that's a couple of wires, a battery, and a bulb. And you also have a worksheet, and the worksheet looks like this. And that's what I want to take a look at first. So get your worksheet, and let's get it prepared, because whenever we do science, you want to keep good records, and you want to make notes, and you do that on your journal or worksheet. So start by, let's put your name on these. Today's date. And I'll tell you, there is a website here. It's a website where I have a lot of my programs and lessons. And if you go to this website, there's a show called Electric Energy. That was in season 3 that goes along with today's lesson very well. You may want to check that out later. Okay, so we have our worksheet, and you notice there's some symbols on it and some vocabulary words. I always like to start with the vocabulary words. And this is my word of the day. This is the word that we're going to focus on. And the word is circuit. Would fourth graders say the word circuit? Now, circuit sounds like circle. And so I'm going to draw a circle around mine, because when we talk about electricity traveling in a circuit, it has a start and goes all the way through, comes back, it has a way in and a way out. So the word circuit reminds me of circle. Now there's a couple other words that we're going to talk about. These two go together. Say the word when I say it. Battery. Source. A battery is a source of electricity. So today I want to hear these words: battery and source and circuit. Two more words. Path. Wire. A wire is a path for the electricity to travel. So I'm going to connect my two, because a wire is a path. Next two words. This may be a new word. Appliance. Bulb. A light bulb is an appliance that uses electricity. So we're going to be having an appliance. Well, actually, we're going to be having several light bulbs. And I have two more sets of words for you. This word we're just going to talk about today, go ahead and say it with me: series circuit. Tomorrow we're going to explore this. I'm going to make a drawing for you, and I'm not even going to tell you much about this drawing. But tomorrow, I hope you understand what this drawing is all about. But I'm just going to do this to give you something to think about. And maybe tomorrow someone can say, Mr. Crosslin, I understand what that drawing means in a series circuit. No, that's not a strange bug with 5 legs. All right, series circuit. And last, repeat after me, parallel circuit. And a parallel circuit we'll explore tomorrow, and this might help you. Check this out. I'm not going to tell you much about this, except for that goes with parallel circuit, and that goes with a series circuit. Check this out. Look on your worksheet. Here's a drawing of a circuit, and I want to see if we can find the different parts. Okay, this is the source. What do we call the source? A battery. Okay, here is the path. And what do we call the path? A wire. And here is the appliance. And in this case, it's a light bulb. Now, watch this. Okay, I brought a marker here. I'm going to start and make my circuit. I'm going to come out of the battery with red. I'm going to go into light. Wait a minute. Okay, it goes there, but the light's not on. I don't know what's going on inside of this light bulb right here. There's got to be a way for the electricity to go in and electricity to come out. In order for that to happen, maybe we should look at some light bulbs. And in fact, I brought some with me today. Here's several different types of light bulbs. Check it out. Here's a small one. That one's kind of hard to see. But I noticed it has glass, metal, more black glass and more metal. Maybe we need a bigger light bulb. Let's check this one out. Oh, here we go. This one has glass, some wires inside of it, metal on the side, black glass, more metal. Maybe if I looked at this one right here. Okay, here's one. Glass, wires inside, metal, glass, black glass and more metal. I even brought this big guy right here. Check it out. Glass, wires in the middle, metal, glass. Oh, look at the bottom here. Look at the bottom of this one. It has a wire coming out of the bottom and a wire coming out the side. I wonder if every light bulb has a wire coming out the bottom and the side. Check this one out. Look here. Right there on the side is a wire coming out. I even have a light bulb that looks like this. A wire goes in and a wire comes out. Maybe every light bulb has a way for electricity to go in and electricity to go out. There's only one way to really test this, and that's to dissect a light bulb. And that's what I'm going to do. We're going to take a light bulb apart and see if we can see where the electricity comes in and where the electricity goes out. So, I think I'll break this light bulb. I got some pliers to try it. It's the dangerous part here. Let's see. I'm going to lay my microphone down because light bulbs, when they pop, they don't explode, they implode. Hopefully, we can hear this one pop. So I'm going to see if I can break this. Now look at the little wire in there. Okay. Here we go. Ready? There we go. Nice. Now I'll see if I can remove the rest of the glass from this. Okay. Be careful of that. There we go. And I was lucky. Look, the wires are still in one piece here. And so I was really trying to see what's going on inside of this. Okay, got the glass out of it. Move this glass off to the side. And here is what's left of it. Interesting. Very interesting. Metal at the bottom. Black glass, more metal. Wire on the side, and wires going up through the middle. I think we should draw this. Get out your worksheet. And right here on the side is a place to draw this. Now there's some new words there too. Teachers and boys and girls, here's the first word, conductor. Say conductor. And conductor means the electricity goes through it. I know that metal is a conductor. Next word, insulator. Say insulator. Insulator, no electricity. It does not let the electricity go through. I know that glass is an insulator, and so is plastic. I'm sure there's other things. So on our light bulb, let's see what we can find here. Oh, look at this. Okay, now, when I was in the 7th grade, I took a class on how to draw things from a science standpoint. So you guys can start with me. Let's start at the bottom of this. The very bottom of this looks like this. Ready? Okay, it's got a bump here on the bottom. It's metal. Okay. And it's got this black section right here. Okay, so this part is metal. And This part is glass. All right, and there's the two parts right there, metal and glass. And now, this is kind of cool. 1, 2, 3, 4. And then this one, 1, 2, 3. And then this thing kind of goes up like this. And that's this part right here. Here's the cool thing about this. Look here, this goes across and across and across. See if you can draw yours like I drew mine. And this is metal. Interesting, we have metal, glass, metal. And there was a wire coming out of the bottom of this one right here. So I'm going to write there was a wire I could see that was stuck to that one right there. And I also saw a wire coming out of the side of this one. There's a wire here. So we got a wire coming in and out. But look what's going on inside of this. Let me go zoom in on this guy. I got two wires coming up. Oh, I see what's going on. Watch this. Look, there's a wire that comes up out of the middle. Now, I learned in the 7th grade that if you want to draw a line, you make a dotted line. That says that means that line is inside of that. Okay? So that one goes up like that. And then this one goes like this. There's my two wires. And this is metal. Okay? So there's one thing that's different about this one than mine. Oh, look what's going on here. Look. I have something connecting these. Now, Thomas Edison was a scientist who studied electricity, and he worked a long time to try to find out what he could put in across this, these two posts that would heat up and give off light. So I'm going to, and if you look at this, check it out. It is a cool material, and it's connected, it's springy. So let's go ahead and draw that on yours. It looks like this. Ready? Just going to make sure it touches, because mine touches. And there's a name for that. It's in your book. It's called a filament. Now all we need to do is add the glass. There's our glass. And let's see if I can follow the path, how electricity comes in this. Electricity goes in the bottom. Okay. And comes out the side. So if I follow that with my red marker, electricity goes in, comes up, goes across the filament, goes back down, and comes out the side. Pretty cool. The only thing I need to show you is this. Check this out. Here's the filament. What happens if I stretch this filament? This is the part that gets hot and white and gives off light. That's still a good one. Oh, look what I did. I broke it. And when I broke it, this little part right here came off. This light will not work now. Maybe you have found a light bulb at home, and if you shake it, you can hear that little filament rolling around inside the light bulb. So the light bulb doesn't work when the electricity can't go across it. So that helps us with this drawing right here. So we know what's going on inside of this. Electricity is coming in through the bottom, going up, going across the filament, coming back down, out the side. Okay, so we should be able to complete our circuit. Electricity comes in, goes out, and back to the battery. Remember, this will help you. A circuit, it has to come in and go out. Come in and go out. A wire is a conductor. Metal's conductor. Glass is an insulator. Metal is a conductor. Metal is a conductor. Glass is an insulator. And that filament is metal. It's a conductor. Let's go ahead and make a circuit by drawing and using some special symbols. If you look on here, there's some symbols that we've added, and these are kind of special. People use them all over the world. It's like a secret language that only scientists and engineers know about. Now you know about them. This is a symbol for a battery. This is a symbol for a light bulb. This is a symbol for wire, when two wires come together and are connected, and for a switch. So we're going to start over here, and we're going to make a drawing of a circuit. Let's start with a battery. Write the word battery here at the bottom of your page. And then we're going to draw a battery. Symbol. Small, large, small, large. You can either look at mine or on your worksheet. Here's our symbol of a battery. I have several batteries right here to share with you, and they all have some things in common. Here is a D-sized battery. It has a positive and a negative. Here's a C. It has a positive side and a negative. This one's called a double A. Let's see if we see the positive. Oh, there's the plus, and there's the minus with the terminals. So batteries have two sides to them, a positive side and a negative side. Here's a triple A. They come in all shapes and sizes. This is a way that chemicals can be used to make electricity. Here's my plus side. Here's my minus side. In fact, I even have a battery that looks like this. You'll be exploring this. This one is a wafer battery, and it's got a plus side right here. I don't know if you can see that. And it has, on the other side must be the minus side. So if a battery has one side that says plus, the other one must be the minus. You can read exactly how many volts they have. This one says 9 volt. And this one here says 1.5 volts, or 1.5. So that's our battery. And we're going to put a bulb up here. And we've already looked at some of our bulbs. So this is the symbol for a light bulb. Go ahead and write light bulb. And I'm going to put a connector here. Here's my filament. And another connector. And I'm going to draw a circle around that for my light bulb. Your teacher has given you a light bulb that looks like this. And that light bulb looks almost like the symbol, except the filament's kind of hard to see inside there. Maybe if we take a closer look, you can see it in there. All right, here's my question. In this simple circuit right here, we have a battery and a light bulb. Will it come on? No, we need a path, okay? We need a path, which is wire. So I'm going to connect a wire from here. Oh, that's got to come on. Okay, let's see if the light will come on. I leave the battery. I follow it around. I get to the light, but I can't get back to the battery. No light. We need another wire. We need another wire. Will this work? Go ahead and draw yours like that. Will this work? Will the light come on? And the answer is no. Look, we're in trouble right here. It's not connected. I know, I'm going to make a switch. Now will the light come on? because I put a switch in here made out of metal, a metal switch. Will the light come on? The answer is no, because it's not touching. I'm going to have to actually make it go just like this. Now the light will come on. Now the light will come on, and I'll be able to follow the path through the light all the way across the switch and back to the battery. We have a circuit. We have a circuit. Draw it. Take your finger, make your finger go around it, and the light will light up. You have two challenges. Challenge number one is using this battery, the simple AA battery, and the one light, and make the battery and the light light up. I want you to use this battery, your first challenge, and this light, just these two things, and make it light up. Your second challenge is to use these two objects, the battery and the light, and some wire. Your teacher's giving you two pieces of wire, and see if you can get them to light up. But first, just use these, and then try it with the wire. And remember, if you always follow what you've learned about the circuit, you should be able to get these to light up. Good luck with challenge number one and challenge number two. So right now, on the bottom, your worksheet right here, while we get ready for the next section, I want you to write, "Today I discovered." I want you to finish that sentence. So you might say, "Today I discovered that," well, you finish it. In our next challenge, we're going to take apart a flashlight that works. It's a special kind of flashlight. One of them looks like this, or you might have one that looks like this, and they both work. They have a light called an LED light in them. They also have batteries, and they also have wires to complete the circuit. You can learn a lot about the world if you take something apart. Often when I try to fix something, I take careful notes to see how it was put together. I take it apart, test the parts, put it back together. And most of the time, I learn more by doing that than if I just would have tried to look at it from the outside. And I also, a lot of times, have a lot more questions about how things work once that I take something apart. So I'm going to take both of these apart. I want you to watch, and then you will do it. And once you take yours apart, identify the parts, use your worksheet to see the source, the path, the appliance, then you should be able to make it light up again. So let's get started. Here's the first one. This is a LED light, and you can see it's got 4 batteries in it, and it's got 4 lights and a switch. When I push down right here, it's got a switch on it. I see some conductors, which are the metal, and I see some insulators, which are the plastic. I'm going to use my scissors, and the first thing I need to do is get some of this plastic and some of this tape off. Plastic is an insulator, and the tape is actually an insulator. So I'm going to pull this apart, and I might end up saving all these parts. I might use them again. If I take this apart carefully, all right, I've got the tape off. Put the plastic off to the side and see if it still works. Yep. Okay, I see some more tape up here. You might, okay, let me take this, and I'm using my scissors, pulling the tape off. I'm going to save this tape. I might use it later. Okay, this gets interesting. Look here, here's my switch. See if it still works. It does. But you know what? It's looks like it's easy to come apart. Oh, the switch came off in my hand. Here's the little switch right here, and when I push down on it, maybe you can hear it. Maybe you can hear it click. Huh. It's a piece of metal that pops back. Okay. Now there's 4 batteries, and I can even see that what kind of batteries they are. This one has some writing on it, and use your eyes, and this says plus lithium battery, 3 volts. And it has some Chinese writing on it, so it must be made in China. If that's the plus side, the other side must be the minus side. Yep. Plus. Okay. I'm going to see if I can take this apart. Let's see. The light comes out. Yep. Okay. And it's hooked to that one battery right there. Maybe I can bend this a little bit. Okay, that's even better. The battery popped right out. Now this battery has a wire hook to it. It's pretty interesting. That battery came loose. Now this battery, take a look at this battery. It has insulation on it. So the only part that really works on this battery is the metal in the center. Unless I pull that, I'll just leave that. But if I'm going to use that battery, I can only touch it where the metal is. See if I can get these guys out right here. Okay, this battery came off easily. And this battery. Now, okay, just like what we did, this is wire on one side. There's wire on one side. To make this work, I have to touch this wire to the other side. Let's see if this will work. Ready? Here we go. Look at that. Cool. Still works. Wire on one side. Wire on the other. If you use batteries, always put them in the same direction. Now I've got 2. And I lost my wire here. But let's see if I can hook it on here like that. Look at that. Okay. Even by just putting them. Now, these lights are kind of special. LED lights only work one direction. So if I got them to work like this, if I turn that battery over, it won't work. Let me demonstrate that with this blue one. So here's my light. It's got 2 wires. So I hook it up this side to this side, it doesn't work. If I turn it around and hook it up this way, it works. Okay, so that's what makes it special. LED light, it only lets the flow go one direction to light up. Okay, you know, the other light that you guys had, the small incandescent light, it would work either direction, this way, or I can flip it over and it still works. Okay, that's an important thing. LED lights only work one way. If I turn it completely around, no light. All right, put that off to the side. That's the square one. Now let's see about this guy and see if it looks similar. It should. First of all, I might cut it out of the package. Plastic, insulator or conductor? It's an insulator. I'm going to take my scissors and I'm going to, first of all, there's a magnet on these. Check it out. See that magnet right there? Well, it says magnet. We'll test it later. I'm going to cut off the bottom of this with my scissors. It's plastic. I'm going to use my fingernails and I'm just going to pull back and peel back the plastic. Oh, I can see some cool parts in here. Check it out. All right, I've taken the plastic off. See if it still works. Yes. Now I see some tape and some hard plastic. Let me pull the hard plastic off. Okay, I might use that as an insulator. And here's my magnet. It comes off. Let's prove that that's a magnet. I'll lay it down there and check my scissors. Let's see here. If it's a magnet, it's attracted to iron. It is a magnet. I might use that later. So I have my magnet, and I'm pulling this part off. Oh, there's my switch. There's our switch that we had before. And there's that battery with the insulation on it. Remember that? If I put it back, let's see if it works. I can still get it to work. There's my switch. I'm going to use my scissors. And you can see the wires coming from one side of the light to the other. And it's still working, even when I'm taking it apart. Okay. I'm going to pull this out carefully and see the different parts I have in here. This one's kind of sticky. These were donated to me by a friend of mine. He used to be in my 4th grade class, and he's a grown man now, and he has a factory, and they make these, and they sell them. And I called him up and said, "Hey, Joe, you got any of those extra cool things for kids to learn about?" And he said, "Sure." And he gave me all these, so let's take a look at this. Here you go. See if I can get it to work. Light on one side, look. On one side and the next, or even double it up, even brighter. All right. Your job is to deconstruct, take apart those LED flashlights, identify the parts, and see if you can get them to light up again. Good luck on challenge 4. All right, we've had a lot of fun exploring circuits. We've learned some new words: circuit, bulb, battery, source, path, wire, and we've taken apart and put back together some electrical circuits. You made a light bulb light up just with a battery, you made it light up with wires, and you've taken apart a flashlight, examined the parts, and put it back together. I would say you're well on your way in becoming an electrical engineer. In the second part of this lesson, we're going to work together in groups and learn about making a circuit to test objects and to make a switch. I'll see you in part 2.